So I don't have a warm up. I want to jump into it. In this chair. All right, guys. So we're going to go on section 4.2, covering quadratic functions and their graph. They look like. We've been kind of messing around a little bit with some of them, but today we're gonna like go really deep into it. So for all of these quadratic functions, we're gonna learn that the parent function of all quadratic functions is f of x, this being the x squared function, okay? Which you guys messed around with during transformation. So all that transformation stuff we covered is going to kind of slowly show itself up here today. And so the graphs of all quadratic functions are called, what are they called? The parabola, okay? They're going to be called parabolas. This guy, and then this is going to be our parent function for all of these. So let's kind of play with one real quick. Let's see, I'm not bad. Okay, so let's look at the function negative x minus 1 squared plus 4. Okay. So look at that function and look at the parent function x squared. Okay. Here, this is just squaring the x, but over there, what is it that you're squaring? X minus 1. So what is that? How would I rewrite that using this f function here? What do you guys think? Yeah, this part here looks like I'm plugging in x minus 1 into f, because that's what's going to be squaring, right? That's replacing like the x. It's becoming the new x. Okay. Is that negative inside or outside?
Outside.
Outside. So that's multiplying the function outside. And this plus 4, inside or outside? Outside. So notice that in this, it looks like that transformation notation. Okay. Here we go, review. What is the x minus 1 doing to the parent function? You're going to add 1 to the x values. What does it do to the graph though? Shifts to the right, 1 unit. Okay. What is the minus 1? Minus, think of it as a minus 1 here. What is that doing to affects the, I heard the y coordinate, it affects the y coordinate and it reflects it. Correct. So it reflects it vertically across the x-axis. So maybe let's write these things. So reflect cross x-axis, and then you guys said this shifts right 1 unit, and then finally, what does the plus 4 do?
Was 4 outside.
Rises it up 4 units. Up 4 units. Okay. So let's take a look. Let's go. Let's see. Let's go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 4, 5, 6. Hopefully, you know what the graph of this parent function looks like. You did it a lot on the homework. That's your good old parabola that starts at the origin. Okay, it has these points right here. Okay, that's just the parent function, that's x squared. So now we're gonna do what you guys learned. I think you guys have normally said from left to right, because it's true, it turns out to cover the multiplication, division before the addition and subtraction. Okay, so we're gonna do this guy first. So we're gonna reflect the parabola. So it reflects it down. So I'll do orange. Oh. Reflect it down. And then we're going to shift 1 unit to the right, so then it moves over here, and then we're gonna go up 4, right? So the vertex goes here, shifts 1 unit this way, and then 1, 2, 3, 4. So it shifts up here at 4. These points of the original function, they went down, shifted 1 unit, 1, 2, 3, 4. So notice that they're going to be right here. So the graph is going to have to look something like this. Hold on, I didn't do this that well. That's fine, sorry. The graph will end up looking something like. Let me fix that. Hold on. It's going to be right there. There we go. And then right here. Okay, so the graph will look something like that. This is the graph of your function g. Okay. Let's just confirm that. Let's go to Desmos real quick.
Here we go. Here we know that's -1 and 3.
We'll figure that out now. But that's going to be part of it. Right now, I just wanted to label everything correct. So if you go to Desmos, the final result will be the blue graph. That's the graph of G. Okay. But do you guys see kind of how we have to use transformations now a little bit faster to give you that result? Okay, so I'm still gonna have you guys practice that. Okay, let's see. So the original quadratic had this low. What were we calling this point down here? Did we give it a name yet? Origin. Okay, so the parabola is either going to have the lowest point or the highest point. Okay, that's what we're going to call the vertex. So originally the vertex was on the origin, but because of all the transformation, this final result, where's the vertex now? 1, 4, exactly. So we're going to call this guy right here 1, 4. This is called the vertex of the parabola. Okay. Right now, let's just label it, and then I'm going to give it some names in a little bit. A property about parabolas is that they're going to be symmetrical. They're like if you cut it in half, they're mirror images of each other. So that line is called the axis of symmetry, where it cuts it in half. Okay. So let me erase all these colors so that you guys don't have too much color to confuse you. So this line right here that splits the parabola in half, this guy is called the axis of symmetry.
Is this only for parabolas?
This is only for parabolas. This is only for parabolas. So today is only focusing on quadratics and parabolas. Okay. What have we been calling the point where a graph crosses the y-axis? Y-intercept. So here, this is where the y-intercept is. And what are we calling where the graph crosses the x-axis? X-intercepts. So these guys here are called the x-intercepts. So on the homework, they're going to give you a parabola. They're going to give you two types of questions. Either they'll give you the graph, and then they'll ask you, what's the vertex? What's the y-intercept, and so on. Or they're just going to give you the equation, and then we're going to have to figure that out. So that's part of what we're doing. How would I figure out all this information now without the actual graph? Plugging things in and solving.
Zero to y.
Exactly. Yeah. So that's where the algebra is going to come in. Okay. So real quick, just so that we have it in your notes. Let's see here. What is the vertex? The vertex is going to be a point. What point is it? 1, 1. Vertex 1, 4. What's the y-intercept? It is 0 and then 3. Good. What are the x-intercepts?
0 and -1, 0.
3, 0 and -1, 0. So notice that a lot of people make a mistake where they say the y-intercept is 3. Intercepts are points, so you have to write the actual coordinates of the points. Okay. And then here's another one. So in this case, the axis of symmetry is the vertical line what are all the x values of this vertical line? 1. So we're going to write that as the equation of the actual line is the equation if x equals 1. Okay. It's a little weird because we've been looking at lines being like slope intercept form, but a vertical line does not use slope intercept form. It's just x equaling where the line crosses the x-axis. Okay. Okay. Questions about the visuals, vocabulary? Okay. So now what I'm going to do, I'm going to do a little bit of opposite. Now I'm going to tell you guys this information, and I'm going to want you guys to graph the corresponding parabola. Okay, let me show you what I mean. So for your practice, I want you to graph a parabola where you're going to want it so that the vertex is at 1, -1, -3. The y-intercept is at 0, 2, -2, sorry. It has x-intercepts at -3, 0, and 1, 0. And then 2 questions. And then what I want you guys to do is find the equation of the axis of symmetry. And then does the parabola open up or down? Okay. So I'm gonna have you guys try that. So you're gonna graph your own parabola that meets all these conditions. Okay. No.
Also, class, please make sure you put arrowheads. Remember, if you don't put arrowheads, it kind of means that the graph stops there. If I forget, please call me out. It's the X value where it's gonna cross the X axis. All right, when you have a picture, just glance to your classmates, take a look at their parabola, see if it matches yours. Just a quick little concept check there. Also, see if you guys agree on the axis of symmetry and what you said for how it opens. Hello, that's it. Be very careful, guys, that your parabolas are, we don't know what this means, but let's say they're smooth like that. There's a nice U shape to them. They should not have any funky stuff like that. They should never do like, they should not look like this. Those are all graphs of different, completely different functions, especially with polynomials. We're going to see stuff like that. So be very careful that your parabola has a nice U shape to it. Where do all my erasers go? Oh. Did I do that? Okay, let's see.
But a U-ish,
Say it again.
but a U-ish.
The best U-ish shape that you can get. But just so that your understanding knows it's a good U though. Okay. All right, so let's see. Vertex is at -1, -3. So you should have had it right there for your vertex. Where does it cross the y-axis? At -2. And then the x-intercepts are at -3. And then 1. So it's going to force your parabola to open up. So we say it opens up when it's smiling. Okay, when it's smiling. But we're going to say it opens up. When it opens up. Okay. Let me label these things: -3, -2, 1, 1, 2, 3. Okay. What did you guys get for your axis of symmetry? X equals -1.
So the axis of symmetry is always going to be the x value.
Perfect. That's exactly right. Because the vertex is that point, is that lowest point, that is kind of the breaking point where you have the symmetry happen. Yeah, and so your axis of symmetry will always, as you were saying, Cleo, be the x coordinate of the vertex. That's exactly right. Yeah. Yep. And so that was actually a remark I was going to say. So remark. In general, for a parabola with vertex h comma k, we're going to call the h the x coordinate of the vertex, and k we're going to use that for the y coordinate of the vertex. The axis of symmetry will be, in this case, it'll be x equals what? X equals the x coordinate of the vertex, h in this case. So that's a nice little fact to help you out there. Yeah, so those will be matching.
Okay. So we've been looking at quadratic equations, and right now we just looked at it in this form, but there's also other forms that you've probably seen or that we've been dealing with. So I want to talk about all those different forms and how each form is going to give you a piece of information about the parabola. Okay? So let's take a look. Take a look. So all quadratic functions can be written, bless you, in three forms. So let's do the example that we just were playing with. Now let me call it f of x. So let's say f of x here equals negative x minus 1 squared plus 4. If you look at your notes, what was the vertex of this the parabola of this quadratic function? What was the corresponding vertex? It was 1, 4, right? So this form is called, this guy here, actually, hold on, sorry. Hold on. This is called the vertex form. Sorry about that. And it's called the vertex form because in this case, the way it's written, because you did x minus 1, the vertex shifted 1 to the right, which gave you that x coordinate for the vertex, and it moved it up 4, which is why it resulted in the y coordinate 4. Okay, so we're going to notice throughout today's class that when I have a quadratic in this vertex form, this numerical value and this numerical value help you identify the coordinates of the vertex. Okay. Okay. Let's see. So now let's say I asked you guys to expand this and FOIL this out. Okay. Notice this is negative x minus 1 times x minus 1 plus 4. We're just going to kind of manipulate it a little bit so that it can change. Okay. Here we're going to FOIL this out, multiply this in here. So we're going to get negative, what is that? X squared minus 2x plus 1. But I have to put it in parentheses because I have that negative. And then we distribute the negative. And so we end up with negative x squared plus 2x minus 1 plus 4 plus 3, right? Well, this guy here is called the standard form. That's the one that you most likely see a quadratic. Okay. The information you get from this form is that notice that if you plug in 0 into x, if I plug in 0 in here, it'll make this 0, it'll make this 0. So what will you be left with? You'll be left with 3, exactly. That corresponds to the point 0, 3. What is that point? The y-intercept. So this, in this form, the 3 tells you the information of the y-intercept. So this tells you that the y-intercept is 0, 3. So for this form, this number and this number was useful to give you the vertex. But in the standard form, the +3 is the y-coordinate of the y-intercept. Okay. All right, here's where the factorings come in. Okay? Questions for how we go from here to here? Cool. Okay. Remember, usually when I've been teaching, when a student has a question about like 2 or 3 other students have that same question. Don't feel you're the only one. Okay, so if I wanted to factor this here, whenever this coefficient of x squared is a negative, it actually makes the factoring a little more complicated. So what we're gonna do is we're gonna take out the negative entirely from all 3 terms. How do I do that? Well, I'm gonna take out a -1. And when I take out a -1, you can think of this 2 ways. Either you divide everything by -1 to see what you end up getting. Or you ask yourself, what do I have to put here so that -1 times this gives me -x squared? So what would go here? X squared. What do I have to put here so that -1 times that gives me positive 2x?
That's starting to do that.
Minus 2x, and then,
Minus 2.
yeah, so it kind of switches the signs of everything. But now this is easier for me because now I can work on factoring this. Okay? Let me do a little side work here for you to help you out. There's hella methods for factoring, okay? I'm gonna go with one called the box method.
You're factoring, the one on the side,
Say it again.
you're factoring that is doing inside the.
I'm factoring, I'm removing what's called the greatest common factor.
No, I saw that.
And I'm taking out that, oh, yeah. We're factoring this right now. We're about to factor that one. Yeah. So there's many methods, but let me go over one that seems to be a little bit more visual for folks. That kind of helps break it down. So this is going to factor into something that looks like this. X plus or minus something here. And then X plus or minus something here. Okay? So there's this box method that says whatever this factors into, I'm gonna think of it like this. I know that X times X will be that X squared. And whatever these two multiply to, they have to multiply to give me -3. Okay? So we're gonna write this term on the top left, and we're gonna write this constant term on the bottom right. And use that to help us figure out what these might be. Okay, let me show you how that works. So we know X times X gives you X squared. What 2 numbers can you put here so that they multiply to -3?
It has to be a 3 and a 1, but you do have to pay attention to the negative because if you get -1x, add 3, then it would be 2x, and that's wrong because in the parentheses it's another 2x.
Right, yeah. So let's just check. Let's just say someone didn't know what you just said. Okay, but yeah, you're right. So you pick a pair that you know multiplies to -3. So then because you picked -1 and +3, then you gotta check it with these ones here. So you would say -1 times x is -x. X times +3, 3x. You know this is the correct way to factor this because see if these two combine to give you the middle term. Is +3x plus -x -2x? No, right? So that means that that's not the correct pair that you want. So I think this is where Khalil was saying, well, another pair that could work is +1 and -3 instead. And then I restart the whole thing again. Let's see. 1 times x, 3 times -3. Sorry, x times -3 is -3x. When I combine these terms, does that give me the middle term? Yes, so that means that this has to factor into what and what? +1, correct. Okay? Okay, so then when you factor it, what am I doing my plug? This is a different form. where I have the -1 outside, I have an x minus 3, and I have an x plus 1. This is what's called the factor form of the quadratic. So you see how for the standard form, if you plug in 0 for x, the y value is 3? Okay, here it's a little different. What can I plug into x so that it gives me y equals 0?
+3 or -1.
Notice that if you plug in 3 here, 3 minus 3 is 0, so it makes everything 0. If I plug in -1 here, it gives that 0, it makes everything 0. Okay, so what ends up happening is that's going to give you the if you plugged in 3, you get 0, and if you plugged in -1, you get 0. What point does this correspond to?
The vertex.
3, 0, and -1, 0. What was special about these 2 points in the parabola that we graphed earlier? Those are the x-intercepts. Okay. So this factor form, this factor and this factor are what's used to help you compute the values of the x-intercept. Okay. So each form gives you a piece of the parabola that you need. This one tells you the x-intercepts. It helps you algebraically with that. This one, the constant term tells you where the y-intercept is at. And then in the vertex form, these values help you compute the coordinates of the vertex. Yes.
So we're gonna go straight from the vertex to the factor.
You can, but you still have to go this way because you still have to expand this and then add that 4.
It's not the standard one.
Yep, you have to go standard.
So standard one is like the midpoint.
No, it's just you're just switching forms. Yeah, this is the more popular ones. This is the more popular. So what we're gonna do today is, given one form, how can I get to the other? So they all give me pieces of information that I need. Okay. You guys see how there's like all these coefficients that keep changing? What is one thing that did not change? Can you guys see something that did not change throughout that whole process?
Squared. The negative one.
The -1. That -1 is this -1, which is this -1, which is this -1. Which is this negative, which is this negative, which is this negative. So on all of these forms, that's the one thing that does not change. It's called the leading coefficient. Yeah, because it's the leading coefficient. Yeah. Okay, good. Good. So now we're gonna that was just with that example. So now let's generalize it. So in general, the vertex form will look something like, it'll be some form where you have your leading coefficient A, in this case, the A was your -1, times x minus h plus k, where h and k are the coordinates of your vertex. We'll write all this out in a little bit, but right now, I just want to give you guys the standard form.
A is that leading coefficient, right?
A is going to be the same A that I write in all 3 of these. So in standard form, it looks like this: ax squared plus bx plus c, where that A is the same A as this one. And then in factor form, it'll be f of x equals a times, what do they call it here? X minus the first x-intercept coordinate, we'll call that x1, and then x minus the second coordinate. And so then you're gonna use. Here, let me slow that. Getting too excited. Eric, what's up?
Isn't there a different way to factor out from standard form when you do a A and times C?
Say that one more time.
I remember they taught us a different way where we would multiply two values and it has to equal up to the sum of the middle.
That's a different way of factoring, yes.
Can you go over real quick?
Yeah, I'll go. Yeah, 1 second. This sweater's dope, but it's like really warm. Representing math club. Let's use this one again to do that.
That's fine.
Is that okay?
Yeah.
Okay, so let's factor this guy again, kind of the way you were saying. So, okay, just so everybody is aware of his question, he's asking, there was a different way of factoring this that didn't use the box method. And let me double check. I'm gonna explain it, but let's just double check that it's the one that you're referring to. So here, what we did is we factored x squared minus 2x minus 3. So there's this method. Explain it again, the one that you were saying.
It's negative. That's good.
Well, here we factored out the negative.
Yeah, right. So
So what we did is we only factored this part. See how that negative one is just this? So all we factored was really this guy. Okay?
Yeah.
Okay, so that's why I didn't put the negative there.
Yeah.
So if I wanted to factor this one, let's see, so again, let's do the same thing. Explain to me the method that you were referring to again.
Well, I wasn't too sure on it, but I'm pretty sure we multiply with see how you go standard form A. If you multiply A and C, and then it has to equal to B. And that's how you factor it. I think you can get the opposite.
Like, you know that you'll use 3 and 1 because
Yeah.
they will add up to be -2. So you know that -3 can work and +1 can work. Because they add up to be -2.
Yeah, I think you're thinking of something called the AC method.
Yeah, that's what
That's a bad one. Okay, that was different. That was different. So for the AC method, here A is 1, here B is -2, here C is -3. This here is called the AC method, okay? AC method. It's a little longer, but it's just kind of more of a process of steps, but it's also helpful. So what you do with the AC method, let me raise this here, sorry. Is there's this little kind of visual associated to it. Where you're gonna put the product of AC on the top. So you're gonna put the product of whatever A and C are on the top, and you're gonna put whatever B is on the bottom. Okay, so like in this case. What is A times C? -3, and what is B? B? And then you put -2. And so then you ask yourself, what two numbers multiply to -3, but add to -2? I'm gonna move this over here, okay? I'm gonna erase it though later on, but. Let's see. Okay, so what two numbers multiply the AC part? What two numbers multiply to the top but add to the bottom? -3 and +1, right?
Yeah.
So then with this method, what you do is you get that middle term. And you're gonna break it up into -3x and +1x. And then you just bring down that -3. So you broke this up into these two. You guys see how this adds to -2? And then you do another kind of factoring method called grouping, which is now that you created 4 terms, what you do is you pair them up.
And then you just focus on each pair. And then you say, what can I factor from this pair? You could take out an x. And then you're left with x minus 3. Here, what can you factor out? Or is there anything to factor out? So you want to factor something out so that whatever is left here looks exactly like this one.
One.
In this case, it's just 1. So you take out a positive 1. And then you're left with just the same thing back. Okay. I know. Good times. So do you see how this term, this is a whole term because it's a product, okay? This term and this term, what do they both have in common? X minus 3. So then you factor out the x minus 3 out of there. Because they both have that in common. So when I factored out the x minus 3, what's left? X plus 1. And that's this guy, right? That's matching this thing? Yeah.
Well, no.
Remember, we're ignoring the -1, guys, because
Oh,
we took that out.
you just have to remember to add that.
Well, not in the factor form. In the factor form, you leave it out. But if you wanna write it back into standard form, yes, you would distribute it.
So it's not in the factor form down there.
It is in the factor form. It is in the factor form. But if I want that -1 to be multiplied back in, I would have to FOIL this out, bring it back in to give me my standard. Was that the one you were referring to? Yeah, B.
I only a different word where I set the equation equal to 0, and then I make everything like x minus 3 equals 0, and the point equals 0, because that's what happens, I cross that out, and then x plus 1 equals 0, and then I solve for x for both of them, and I get this
X-intercept, correct, yeah.
Well, alphabetic, yeah.
Yes, yeah, which we're gonna do that as well.
Okay, that's good. I know you gotta do that with polynamials, because where there's a coefficient, because we're took down x and I do all that stuff.
You gotta do all that stuff, correct. Was that the one that you were referring to? Okay. Okay, so we'll do another one, and if it shows up, I can play around with the factoring method, okay? I'm gonna erase it though. Okay, so for these 3 forms, again, these give you key pieces of information. And so let's see, so I'm gonna make up a parabola, okay? You guys remember when we were graphing the original parabola? This -1 reflected it. That's what forced the parabola to go like that. Okay. So if it's negative, the reflection piece makes it go down. But if it's positive, no reflection happens, so then the parabola is happy and it stays smart. So it opens up, okay?
It's taken on its side with the axis of symmetry, the y equals something.
That will never happen for this type of quadratic function,
Okay.
because then it won't be a function, it fails a vertical line. So, let's pretend this is a parabola, some random parabola associated to this general function, okay? From what we have here, what should be those x values of the x-intercept? From what we have here, here, and here.
Oh, that's one.
X1 and X2. Okay, because remember that, oh, I erased it, that gave us the x-intercepts here. So this is going to be X1, X2. What is the y-intercept? It's going to be the C value. Okay, what are going to be the coordinates of the vertex? H and K.
Oh, yeah, sorry.
H and K, it's all good. And so that's kind of the algebra that you're going to look at and the graphical like information that it's telling you. I'm going to have you guys practice it. Okay, so it's okay if it's still a little fuzzy. And then the remark
that we were just discussing.
Oh shit, I need more room. Hold on. There's actually a bunch of them. All right, so then we have some important remarks that are gonna help you here. So the first one is, if that leading coefficient A is positive, so it's greater than 0, the parabola, did it ever reflect? It never reflected? If it's positive, no, right? So then it's gonna stay smiling. So then the parabola opens up. If that A value is negative, that's gonna force the reflection across the x-axis to happen. So then the parabola opens down. It's negative, it's feeling, had a bad day. So it's gonna open down, it's frowning. And then the third one is going to be very useful. So let me mark that in blue, actually. The third one is very useful. So given the standard form f of x equals ax squared plus bx plus c, to find the vertex of the parabola, we use what I'm going to call the vertex formula. Where there's actually a relationship between h and the coefficients a, b, and c. Okay, and that relationship is h is going to be equal to negative b over 2a. Throw back for some of you. Okay. So once you know h, once I know the x coordinate of h, k is supposed to be the output of that x coordinate. So then how would we, and once I know h, how can I use the function to find k? Go back to when we were learning about what a function was in its graph. If a point lies on the graph of a function, what's the relationship between the x coordinate and the y coordinate? No, not quite. Think of inputs, outputs. X is the input and h, or the y coordinate is the output of which input? Of that guy, right? So if I know my h, to find my k, I literally just plug in that h into f, and that gives me my k.
So this was a general solution for like the new sharing last time with the multiplying to
This is a general formula that will work for, for any type of, exactly, yes. It's a general formula for that. Yeah. That's a great question. Okay, so let's do a brand new problem. I'll go little by little, then I'll have you guys fill in the blanks for me. So you guys can kind of see, we just need to keep seeing more examples to kind of put all these pieces together. Okay, so for the function f of x equals 2x squared plus 4x minus 16.
The first question is, find the x-intercepts. And the x-intercepts. So let's see how we're gonna figure that out.
So you guys see right here on this graph? We have the x-intercepts right there at these two locations. What, if I was to write this as a point, what would be the coordinates of this point right here? X1, and what's the y value? 0. What about this one? X2, 0. What about any x-intercept? What is always true about the y coordinate? Always has to be 0, because it's on the x-axis. I know, so much theory today, guys, sorry. Okay. So yes, that's the property about the x-intercepts, is that y always equals 0 there. So now I'm gonna go off a little bit what B was saying earlier. When you guys need to find the x-intercepts given the function, are you plugging in 0 and for x, or are you trying to figure out what x gives you 0? What x gives you 0? Because you're trying to see what makes the y value equal to 0. I'm gonna do both, actually. I'm gonna do both. Yeah. So to help you answer this question, what you need to do is you need to find x so that the function will equal 0. Because that means the y value will be 0. So what we need to do is we need to set the equation equal to 0. We need to see when it'll equal 0. That'll tell us when the function. So we're going to do this in two ways, okay? Because I just want to review all that stuff for you guys, and then you pick whichever one you want. We're going to do it by factoring, and then I'm going to remind you guys of the quadratic formula. Good time. Okay. Okay, let's do the factoring way first. You actually hold on before I do that. One thing that you could try to do before you start like factoring and all that is see if do you guys see how all of these terms are even? So that means that we can make this equation actually simpler by dividing everything by 2. Okay. But when you're solving an equation, only divide by numbers, not by variables. So I wouldn't want to divide everything by x. I'm just foreshadowing for later. You don't want to divide things by variables when you're solving because it might make you lose a solution accidentally. But it's okay to divide by numerical values. You won't lose solutions that way. Okay, so all these are even. If they were all multiples of 3, you would divide everything by 3 to make it simple. So everything needs to be divided by 2. Everything, not just like a couple terms, like everything needs to be divided by 2. Okay, so that'll make it a little simpler. This becomes x squared plus 2x minus 8 is equal to 0. Okay, so from here, let's do the factoring way. Can I have you guys factor it real quick? Just work that out. Try factoring it. You want to practice your own method, or you can do the box method, or the other AC method that we were looking at. You can do that one. Try factoring it. If you're confident with your factoring, maybe just help a classmate out.
Go ahead and ask those questions.
What happened to
Do you know you did it right? If we combine these two terms. So then this is where.
This is like the one.
We'll just keep practicing.
And I put one of the AC method.
Here you want me to add. You have four. Yeah.
Because it doesn't multiply and add.
Yeah. And that's why I did add.
Or it's no. That's like a zero. Yeah.
All right, guys, we're gonna move on. So what did it factor into?
X minus 2, X plus 4.
X plus 4, all right. Okay. So you can think from here, you can think of this process in two ways. Either you can ask yourself, what can I plug in here to make this 0? And what can I plug in here to make this 0? Or algebraically, this splits up into, you literally write that. When will this equal 0? Or when will this equal 0? And you create your own independent equations to see when they're 0, and then you solve them. Add the 2 to both sides, minus the 4 to both sides. Okay, yeah, question.
You factor the 2 out on the top, right? Okay. We factored it too out, right?
You can factor it or you can divide by it when you're solving. When you're solving. If I would have factored it. If I would have factored, I know so much. If I would have factored it, it would have looked like this.
Mhm. Now we're trying to, if we kind of find the factors.
But then now you still need to factor this to that.
It's actually-
Correct, the factor for. Correct, correct. Yes,
So you can just divide it by whatever, because dividing 0 by anything doesn't do anything.
correct. And also because you're solving an equation. Whatever you do to one side, you can do to the other.
Now would the final answer be that 2x minus 2x plus 4?
No, the final answer is what are the x-intercepts?
Oh, okay.
So is that the answer?
No, you have to write them like.
You have to write them as points. The actual x-intercepts are 2, 0 and -4, 0. Okay. All right, let me quickly review the quadratic formula. Just to show you guys, there's like all these different ways. That's why I was a warning, give you guys a warning. Let's say I would have done it and I didn't want to factor. And I wanted to use something called the quadratic formula, which is a formula that gives you these x values, and let's set it equal to 0. So here, what you need to do first is identify what is the a coefficient, what is the b coefficient, and the c coefficient. This is 2, -16. Okay, so you use the coefficients, and there's a useful formula that helps you solve those x coordinates that we just did here. This really big, ugly fraction, okay? And I heard there's a song, I never heard about the song. But negative b, that's that formula. Luckily, there's a note sheet allowing the test. But you guys should definitely try to memorize it if you can,
I'm pretty sure the song is just people saying it in like a song voice.
in a song. So the way it works is you plug in those coefficients into the corresponding formula, okay? So that negative is always going to be there though. So it's -4 plus or minus 4 squared
Minus 4 times 2 times
-16.
over 2 times 2.
2, okay. So then we keep going, -4 plus or minus, let's see, what's that, 16? And then what's -4 times 2 times -16? 128? Okay, but you see how I'm multiplying it, I'm including the negative? So it's negative times a positive times the negative will be a positive 128. Okay, over 4, bring it over here. So then I got -4 plus or minus, what is that right here? Is that 144? Oh, it's convenient. 144 over 4. What's the square root of 144? 12, beautiful. Okay. If it factors, your answers are usually pretty clean, correct? Yeah. So the reason you get 2 solutions is because of this plus or minus. Okay. So what ends up happening is that this splits up into two cases. So one, you do -4 plus 12 over 4. And the other one is -4 minus 12 over 4. What's -4 plus 12? 8 over 4, which is 2. One of the, oh, that's not my answer. One of the x values. And then here, this turns into -16, which is -4. So that gives you these 2 solutions.
So we can do either one.
You could do either or. Yep. But I would suggest you practice factoring, because polynomials, this doesn't affect a lot. Polynomials. Okay. Let me just tell you one more thing, I'll take a break. Okay? Any questions on this though, before I say it? Okay. Remember how I told you guys when you're adding or subtracting two things on the top over the same denominator, you can break them up into two fractions? So I want you guys, let's just kind of explore the quadratic formula here. They're both over 2a. So I can rewrite this as two fractions. What's one fraction? Over 2a plus or minus the square root part 2a. Okay.
So do you guys see how on a parabola, the vertex is where the symmetry happens? Okay. And this formula says that the x coordinate of the vertex is always negative b over 2a.
Wow.
Okay, that's this guy right here.
This is where the vertex, the x coordinate of the vertex lives. And then if you add this component, that gives you one of the x intercepts. And if you subtract, that gives you the other guy. Okay, so this is saying like the vertex coordinate is in the center and the x intercepts are one's to the right, one's to the left if you add or subtract by that same amount.
I have a question. If
Yeah.
you use negative, then in this case would be 3 over 2.
If b is a negative, the negative and the -3 turn into positive. Yeah, which will that comes into some of the problem.
So I just kind of wanted to show you why this formula looks like that. It has to do with the quadratic formula, the little theory under that. All right, guys, let's take a break. I'm gonna leave this on the board so that we can practice some of the stuff.
What's in the next section?
What is in the next section?
How much?
We're not done with this section.
Oh, we are. How
No,
much is in that section?
not a lot. Not a lot. Okay. So that was just to find the x-intercepts. Okay, but it just took a while because I was trying to review all these different methods. The other questions I wanted to ask is, let's say you're given this function. Notice that it's not in vertex form, but you're asked to find the vertex. Okay, so let's see, how would we do that? So let's say they tell you to find the vertex. H comma K. So one of the remarks I made, we were talking about how when you were given a quadratic in standard form, we were able to find H through a little formula here, called, I was calling it the vertex formula. What was it here? 2a, exactly. So we, again, just need to identify that A here is 2 and B here is +4 to help me figure out what this H value is. So it's going to be -4 over 2 times 2, which is -4 over 4, which is -1. So that tells you H is -1. How did we find our K? Yeah, now that I know the x coordinate of the vertex, I just plug it into the function to give me the y coordinate. So K is going to be f of H, which in this case, I'm plugging in -1. So what you're going to have to do is you're going to have to plug in -1 into your x's here. So that's going to be 2 times -1 squared plus 4 times -1 minus 16. What's this right here? +1 or -1? +1. Be careful because you're squaring, you're multiplying -1 with -1.
So that's really just 2 times, this is really just 2 times 1. This is gonna be 4 times -1 is -4. So what's 2 minus 4? -2 minus 16, -18. And so what's the vertex? -18.
Why did you get the 4 there?
This guy?
Oh, wait, no, it came from that, never mind.
It came from this, yeah, sorry. Came from that. Yeah, this became 2 minus 4 minus 16. All right, so let's see, that answer, we got the x-intercepts here. We got the vertex formula here. What's the y-intercept? Given the standard form. 0, -16, so that one I'm not gonna do here. And then the last question is rewrite f in vertex form. And remember that one looks like this. Do we know the leading coefficient A from the previous work? What is our A here? Remember that A is this A. Okay, so notice we have from what we know. So from the function, the way it looks right now, we already know that A is equal to 2. We just found H to be -1, and we found K to be -18. So these are the 3 missing pieces of information that I need for this form. And so if I put all this together, that's going to be A is 2x minus -1 squared minus 18. So let me clean that up a little bit. 2, what happens here? Plus 1 squared minus 18. And so let's just double check. This was a web design problem. Let's just confirm. Don't go all the way. Don't go all the way. Okay. Let's just see. Let's see here. Let me move it up a little bit. Oh, it does that for me already. Okay. So let's see. F of x equals 2x squared plus 4x minus 16. 16, right? Yeah, okay. So let me see. So the vertex is telling me is at -1, -18, which is what we got. You guys tell me the y-intercept is at 0, -16. The x-intercepts we found are 2 and -4. And then if I rewrite this function as, I don't want to write f. Let me just write y equals the vertex form. 2 times x minus 1 squared minus 18. Oh, plus 1. Boom. Yeah, there you go. I got scared there. It's like, oh no, it's not matching. So correct. Both of these give you the same graph. They're really the same function, just written in different ways. Okay. So I'm going to have you guys practice some of these. Obviously, you see you need a lot of work. So try to do them on your notebook. At least the first 3. Okay. One quick thing real quick. Let me move this up. Hold on. No, I'll just do, hold on, I'll just mention. Save time. Okay, so. Something else that the homework's gonna ask you is they're gonna tell you, they're gonna give you the function. And they're gonna tell you, find the small or like the minimal y value. Or find the maximal y value, like find the minimum and the maximum. But it depends. You guys see how this parabola is facing up? So at the vertex. Let's say I asked you guys for the range. What's the range of this function? What's the smallest y value? -18, right? And then it goes up to infinity, right? But if the parabola was facing down. If the parabola was facing down, now what's the range? Up towards -18. Right? So in this case, -18, let me zoom in. In this case, -18 is the maximal y value. Because it's the highest, it's the peak. Versus if the parabola is facing down, facing up. Now it's the lowest point, correct. So that's one thing you guys are going to want to be careful with. So that's what the second page is going to talk about. Okay, it talks about finding maximum and minimum values. You start by determining, is the parabola facing up or is it facing down? Okay, question.
If that's the maps and it's playing up, would the answer be like thinking it?
There is no maximum. Yeah, so if it was like this and it said find the maximum, you would say there is none. Yeah.
When you said that A is greater than 0, the problem is open.
Correct.
If A is equal to 0, A is equal to 0, so that's, is that what possibility?
It was not a possibility because if A is 0, then you don't have a quadratic. Yeah, you have a linear function. Okay, guys, so I'm gonna pass these out. 1, 2, 3, 4, 5, 6, 7. The front is gonna ask you questions like what we just did. The second page is gonna ask you questions about finding maximal and minimal values, which rely on the vertex. And then the third page is not really required, or it's not kind of what we're doing today. It's just hella practice on factor. Okay? All right. Okay, no, we just think 1, 2, 3, 5. 6. There's not enough space, so please do problems, the first 3 problems on your notebook. There's not enough space. You need to answer questions A, B, and C on the plan.
Right, these probably work with your group, so you three here can work with each other. You, let's see, you think you should work here, right? Together? Say it again? That's it.
Please check in with your group. I know this question answers, find the y-intercept, the equation of the axis symmetry, the x coordinate of the vertex. Actually, it should say find the vertex and the x-intercepts. I need you to find the x-intercepts too. Let me get that worksheet. Let me do that. Otherwise, I'm gonna forget. There's not enough room, yeah, so just do them on your notebook. There. What's this one called? Graphing quadratic equations. Graphing quadratic equations. Find the y-intercept equation. Yeah, perfect. All right, while you guys do that, I'm gonna post the solutions on the week 6 module. At the end of finishing a problem, you should have a graph. Using all the components. Remember, there might not be enough room on the worksheet. You want to pass it over to your notebook? Because if you're not writing in tiny letters. Mhm. Mhm. Yeah. Now we do this, we want to coordinate. Yeah.
So what I was saying is after that. Part of it. And she's saying, and they have something. Correct. A is greater than 0. Well, A is greater than 0.
Well, yeah, I know.
Well, we're doing this in this actual. So there is a point of view, so we're going to use this one. So I think you're jumping a little bit. But maybe it's unused. When you rewrite this name, you have to say this one is for that one. This one is for that one. Now from here. Everything.
I just. It's that number 6.0. We work this is negative. What's the minus of actually gonna do it. So you should.
Why is this?
So you know, we're.
I don't know.
Oh, no, I'm registering for a register.
Oh, I know, I just.
So you can apply for them? Because
Oh.
when you're taking this kind of the raise, the raise things.
Like, see, like, I'm not even sure. Yes.
Your notes on this? Yeah. Numbers. I guess. What I did is I just. This will go on and this will be fine. Right, I did. Like I. One time they went in time with. That's good.
All right, trying to go to the second.
Can you use the quadratic formula? Yeah, but.
You could use a quadratic formula.
Cause I'm also not able to factor the second one.
The second one? Okay, let's look at the second.
It's that negative, right?
Yeah, and how
Yeah.
it flips in.
So I erased it, but remember,
You could divide it by -1.
You could divide it by a -1, or you could take out a -1, like what we did earlier.
Yeah,
Okay.
I took it out and so then the one that's this one.
Let's see. Let me take a look. Hold on, you take a look.
Still recording, right? Yeah, okay. Are you guys talking about number 2, right?
Yeah.
Okay, so let's see, number 2. And you guys are trying to find the x-intercepts? So what you're doing? Okay, so we're gonna set the equation equal to 0. All right, and so what did you guys do so far?
Divided it by negative.
Oh, wait,
Divided by -1,
wait, what happened here?
minus 2x.
Okay, so you divided everything by -1 in this case, okay? That's one thing you could do, or you could factor out a negative. Okay?
And
So-
then we did the square.
So here you should get a plus,
Yes.
and then -2. Yeah, it's not gonna factor.
Yeah, it doesn't
So
affect.
you need the quadratic formula.
Yeah.
You need the quadratic formula.
It's gonna have to be like a squared plus abx. Plus a squared plus. Or, sorry, ax, no, yeah, it is a squared plus ab plus c squared.
For the quadratic formula?
No, not quadratic formula, like, sort of the factoring, it has to follow that. Right?
Oh, yeah, yeah. Yeah, like if you try doing the AC method, and you multiply A with C, and you bring down the B, there are no numbers that will multiply to -2 and add it to it.
Yeah,
Correct.
so that's, yeah, that's just the method that I learned was the,
That, what you just said is kind of what's happening here.
yeah.
We just. Let's do one.
Yeah, guys, so for this one, you're gonna need the quadratic formula. Yeah.
Just fine. You guys gotta practice it.
Yeah. It was fine.
Should let me check something.
Need the quadratic formula. This back. You won't have enough space in your works, you guys, please. Especially with the quadratic formula one. You know, reference that to that.
Wait, I assume so. I just leave it like that.
As soon as that. You can, but when you graph, you're gonna need.
Well, you can't really, I mean, you can go into. Well, you wouldn't use the decimal for the graph on decimal. Because it would be like. You just put in three, right?
No, there's negative one plus with the.
And then one, yeah.
And then that would give you the
I mean, you
decimal.
could just leave it in the X.
Yeah, it's, we can't use that to graph it. Or it would be ugly.
No.
It would be a.
It's very good.
It's not nice.
Yeah. 3.5. So we just use it.
What? So what you could do is you can take out no extra.
This one. Yeah.
And then these ones for four.
Here.
Oh, yeah.
Connected.
Yeah.
Let's make it to the-
Yeah, you have to break it down into perfect.
Yeah, you can always divide out. So you can just have it each out. This one.
But so it's not.
Yeah, over the. Square root, 4 times 3, you get rid of the 4.
Yeah.
Like if you 2 on the outside, it's like 3.
Well, because then you think that's just.
Guys, real quick, real quick. If you're using the quadratic formula and you end up with a negative inside the square root, what did we say at the first week of class? If you have a negative inside the square root, what kind of number is it? It's an imaginary number. We can't graph that. So in this case, there is no x-intercept. There are none. Meaning the parabola either looks something like this, where it never crosses the x-axis, or it's like somewhere down here where it never crosses the x-axis. That's the algebra telling you it never crosses the x-axis.
Wait, sorry, it's happening too?
No, not on number 2.
Yeah, okay.
I'm just saying it might happen. Yeah, so if you get an imaginary number, that tells you there is no x-intercept.
Oh, yeah.
Everything gets divided into 2. You can't cancel 2, so it's down. That's a pretty big mistake. You always have to divide it all on one side. Yep, perfectly fine. And that's why we actually backed it up with 2. So that we can get a nice. Negative 1 plus the square.
Okay.
So you can, but like, you would have to just plug in this number. You know, you wouldn't make it adjustment, when you plug in one minus. Correct. Yeah.
Okay, yeah, I got it.
Plus this for three. The one. And that's what you would write on the graph. There's just no different way to put it. You gotta reduce that. Yeah, that's right. And then, so square root of 12. What two numbers can you make the flow into? So. Square root of. So, or let's say the square root of 4.
So it's like that. Oh, yeah, no, you didn't go like, all right.
Well, it would be the square root of 4. And then.
Minus one.
What's it?
Yeah, that's the.
Okay. Correct. It's correct. So the thing like that.
Yeah, what I forgot about.
This is where all this stuff will.
I got here, but yeah, no. If I can't.
No, those are irrational. So your graph is in the cross. The x-axis. That was. Put them in your calculator. Those are going to be some nasty decimals.
So basically, the response.
No, you use the calculator to approximate decimal. Yes and no. Still do it on one. You can split it up. You can split it up as 2 over -2 plus or minus 2 root 3 over 9.
Yeah.
Because it's 2 units.
Okay, that means.
You guys get that? Open this one. The second expression, negative, I got on 1. Right. Where? Yeah.
Yeah, I had the number one and the that's. Guess it makes sense.
The other than like, okay. I was now on at home. Over. There's no nothing to keep track.
Yeah, I think, yeah.
Thank you. Now you have this sensible feeling and everything like. Hoping that I constantly hear constantly. Thank you. Again, you see all of these. The homework is like. It's not.
I did. I got.
You just can't.
Oh, you said this.
Class, real quick, for number 2, if you get your x-intercepts, you get something like this. For your x-intercepts. And you use the quadratic formula. Okay, that means that one x-intercept is gonna be here, and the other is gonna be here. Okay. Remember on week 1, or on the test, I gave you guys all these weird numbers, and I told you, is it an integer, is it a natural number, is it rational, is it irrational? This is where it's coming in now. Okay. What kind of number is this? Is it an integer? Hell no. It's gonna be irrational. It's an ugly irrational number. So what do irrational numbers look like? Decimals. They don't terminate and they don't repeat. So you're gonna need to approximate this decimal value to know where your graph crosses the x-axis. Okay, so help me out here. What if I put this on the calculator? point 0.73, blah, 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 right? So we're rounding it to 0.73. And this one rounds to negative 2.73. Okay, so you're gonna have to use a calculator to compute the decimals, round them. So I could have rounded it to negative 2.7 if I wanted. Actually, let me do that. So what does that mean? That means on my 1, 2, 3, 1, 2, 3, my graph needs to cross the x-axis around 0.7. Because here's 1, 2, 3. This is why I was doing all this week 1. Okay. And at negative 2.7. So that's about right here. So your graph should be crossing around here and then around here. Okay? So just a small little annoying detail. But it is what it is. Like you guys need to practice knowing stuff like that. So it's okay.
Yeah, we did 4
All right, guys, let's take a little 5-minute breather. We're done with this section. I wanna go over 4.5. So let's take a 5-minute breather. 2:56. You can keep working, that's fine. But if you need to go take a bathroom break or something, go for it. Yeah. It means there is no.
I didn't think it was like consensus. No, it means it's a process.
Oh, okay.
Yeah, there's still a verse that I didn't with my number, but it's.
Are you, well, what are you doing with your, okay, so you gotta make sure you set your equation. That's the work that you need to show. So set this equal to 0, and then that's what you need to have.
Everything is.
I mean, conceptually,
You can't cross it out, it's not on the other side, it's on.
I think you got it.
So this so
It's still.
Read this. You.
the way to think about it. One time,
But I think you equated it.
But another way of doing that is.
When it's really
Right.
One negative 1 times the x was 0.
So that's what
Yeah, when you it should be around there.
Oh, let's go for it, write it down. So actually write the equation 2x minus 1.
Yeah, like it's.
And then, yeah, and then 1 just x minus 3, and then you just solve for x. Yeah, so it's a little bit more like systematic.
Something.
So 3 uses the formula again.
Citizen,
Yeah, so uses quadratic thing. Or no?
if it doesn't factor and you try to, yeah, if it doesn't factor, then you're gonna want to try to look at that. Yeah, I think it does. You could double check when you use them. Actually, There's no volume, huh? Oh, boo. Okay, this recording. All right, guys, we're gonna move on. Sorry. Gotta keep going. All right, I have a little video to introduce the next section, okay? Bring it back, bring it back. Bring it back, guys. Quick little video to introduce the next section. I don't know, I can't get the volume to work, so I apologize. There we go. All right, so there's no audio, I apologize, but let's take a look at the Mario game. Just see what's gonna happen. Who's played this game before? This one. All right. You can see that parabola? That's right. So when you're coding the game, you have to try to do it so that it mimics the motion in real life, right? Like, why didn't Mario jump like that and then kind of do this weird feature? Or how do you do it so that it feels real, like in the real world? And so in the real world, usually motion, when it goes up and it goes down, there's a parabolic path that it takes. Okay. So you got to kind of mimic that in the coding of the game. You got to somehow tell it to give it that motion, and that's where the quadratics would come in. What did they say? Okay, that's it. Yeah, it's more fun with the music too, because no one cares about Luigi. Let's go. I'm just kidding. I'm kidding. I'm kidding. I'm kidding. I'm kidding. I'm kidding. Haunted Mansion Boston. Okay. Turn on the lights. All right, guys. So the next section uses a lot of the tools that you just did. So the hard part is what you guys just did for this next section, okay? But it talks about using quadratic functions to apply it in the real world, and I'm going to focus just on motion. So the last few problems in your homework, we're going to talk about this. So quadratic functions in the real world. And so if you end up taking a physics class, you'll observe that objects that go up and down go up and down in motion. Do it in a parabolic way. There's a parabolic path that it takes. And we're going to use quadratic functions to model that path. And so if I have, here we're thinking of motion, and so we're thinking of an object. So we're thinking of the y-axis now, we're going to call that the height axis. Okay. And you have the height. Here we're going to call the height h. And you're looking at the object and looking at its height as time is passing by. Okay. Usually they use the variable t for that. And so there's all kinds of different examples, but if I grab the rock and I throw it up from here, was the rock initially at height 0? No, there's usually some kind of initial height that it can start at, right? Whatever my hand's at before I throw it. So whatever that initial height is, that object, let's say you throw it up, and then it's going to have to come down. Okay? And it will do it in a parabolic path. So there's a quadratic function hiding in that path. Okay. Right now, we're just saying the parabola keeps going down and all that, right? Like the mathematical parabola, and the mathematical parabola does go this way. But when you're using it to model it in the real world, we don't think of the time being negative. So we're just going to consider what happens at time 0. And it's the case, maybe this is like water or something, so that you're looking at the height below the water. Okay. But in this case, let's say we're looking at when the object hits the ground. Okay. Let's use all the vocabulary that we just learned about parabolas to describe this model. What is that? That's the y-intercept. That's the initial position, right? So here, the y-intercept, you're going to interpret it as the initial position, where the object was at time 0. Okay. What's that? That's the x-intercept. That's where the object is at height 0 or it's on the ground. Okay. So this is where you have height 0. And in this case, the parabola is facing down. What are we calling that point? The vertex. But what information does this tell you about the actual model of the object? It tells you where you're going to have the maximal heights. Okay, the HK that you guys have learned about. The H here tells you what information? Is it H? Is H time or height?
T is time.
Shit, sorry, little h.
Oh,
When I was grading someone's problem, I wrote a comment. At some point, using a lowercase and an uppercase is going to matter. Here's an example. Okay.
yeah.
Little h here is the x coordinate or the t coordinate of the vertex. Okay, so it's representing time. But what is special about this time? What's happening at this little h time? That's where you have, that's the time where you have maximal height. What is the maximal height? The y coordinate or the height coordinate. Right there. Okay, so what the information that this tells you is it's telling you the maximal height h equals k at time t equals little h. Yeah. And so
everything that we just learned and everything you guys just learned to find actually has meaning now in this model of this problem. There's like actual units to it and everything. So let's do one problem. So you guys can kind of see how you're going to do this on the homework. So let's say we have if an object's height h, let's say it's in feet, at t seconds is modeled using the quadratic function h of t, because now h is like the y and t is like the x, negative 16t squared plus 80t plus 40 at what time did the object reach maximal height? Right. And then also, what is the max height? What is the maximum? This is recording perfectly. Okay, so take a look at it. So an object's height h in feet at t seconds is modeled using this quadratic function. At what time did the object reach its maximal height, and what is the actual maximum? So one thing I'm going to suggest that you do when you're working with word problems and they give you a function is understand what the input is doing and what the output is doing before you even start anything, okay? So if I plugged in a number, give me a random number for t. 3. You plug in 3 and you get some number here. Let's say it's 60. What does that mean for this problem? At time 3 seconds, the object's height is 60 feet. That way you kind of understand like the dynamics of what this is doing here. Okay. All right. Let's see. Let's get a feel for what things that we do now. Hopefully with the worksheet, there's some things that you can know right away. One is the y-intercept. What's the y-intercept here? 40, that constant, right? So it's at 40. How is the parabola shaped? Is it facing up or is it facing down? How would you know? The A is negative, so it has to face down. Okay, here A is negative 16. That tells you the parabola is facing down. Okay, so if you know, we know the parabola is facing down now, and we know this is the y-intercept. So do you guys see how it's going to have this kind of motion like that? Okay. So to answer this question, it says, at what time did the object reach its maximal height? Mathematically, what do we have to find? Do we have to find the y-intercept, the x-intercept, or the vertex? You need to find the coordinates of the vertex to help you answer that question. Okay. What about the second question? What is the maximal height? Which of these three will help us do that? Vertex. The vertex. The maximal height is going to be that y coordinate of the vertex, and the time that it happens at
is the little h. Okay, so to answer these two questions, that was weird. To answer these two questions, we need to find the vertex, little h and little k. Okay. So let's see. So h is going to be, what's the formula we're using? 2a. So what's b here? It's going to be negative and then, yeah, 80. So negative 80 over 2 times, what's the a? Negative 16. So help me out here. This is negative 80 times negative 32, which is 5 halves,
Or, yeah, 2.5.
2.5, 5 halves, which is 2.5. Okay. What does that 2.5 mean then? That's the time that you're gonna have maximal height. We found it, it's right here. 2.5. Now, we need to answer the second question, which is K. And so what do we have to plug in? 2.5 into the, oops, shit. Into our function, here it's called H. So you gotta plug in 2.5 to give you that. Oh gosh. Let's see, so negative 16 times 2.5 squared. Help me out here, calculator folks.
Negative 40, 200. Negative 100 plus 200 plus 40.
Negative
100 plus 200 plus 40.
plus 200 plus 40, okay? What's that? 104. So that tells you negative, sorry, positive 140. So that's the maximal height. Okay. So now, how do I answer this in English?
At 1 seconds, the object will reach its maximum height of 2.5. I don't know what you mean.
Seconds.
Is this the seconds or is this the seconds?
At 2.5 seconds, the object will reach 140.
A maximal height of 100.
Yeah, seconds.
At t equals 2.5 seconds, the object reaches a max height of 140 feet. Question, yeah.
When you say the equals on that one, but not.
You're right, you're right. I don't have to say that. I don't have to say that. It's just, you don't have to. At 2.5 seconds, the object reaches a max height of 100. So what you're gonna do is you're gonna look at the question and then ask yourself, go back to math and say, what do I need to answer that question? Do I need a vertex, x-intercept, or y-intercept? What kind of question can you guys think of that I need this right here?
What time will the object hit the ground?
And what object will the object hit the ground or stop its motion?
On website, would it have like that kind of sentence already formulated, inserted?
On WebAssign, it's gonna say things like,
Is it like fill in the blank?
it's a little bit of fill in the blank, yeah, yeah. So it says, find the ball or find the maximum height of the ball and the time, and then you put h equals blank, t equals blank. Be careful, man. Here they use little h for the function. Okay, just be careful.
Okay, that's a non-account related question.
Yeah, let me just close this up. All right, guys, we're done. Good job. All right, we got 1 minute left. That's perfect.